Unit number 2, operation amplifier applications. Okay, so in this chapter we are going to discuss about the different application of operation amplifier. So that is operation amplifier comparator. So we already discussed with the open loop and the closed loop concept. So comparator used in the open loop model. That is, comparator finds it's important in circuit where two voltage signals are to be compared and to be distinguished in which is stronger. That is, it is going to compare to signal. That is, we in comparator we have three terminal, two input terminal and one output terminal. If V1 greater than V2, output will be 1. If V1 less than V2 means output will be 0. So this is the simple concept. So if you are giving input as a sine wave, it is comparing the input and it will give the square wave output only. That is, comparator of output always it should be 0 or 1. So this is the basic model. This is the maximum used in the analog to digital converter circuits and digital to analog converter. They are using the different comparator model. Okay, that is a concept. That is, V in greater than the V reference means output will be V plus VCC. If V in less than V reference means V out is equal to minus VCC. So the principle used in the comparator circuit is two inputs and one output. So non-inverting comparator having two types. One is a non-inverting comparator and one is inverting comparator. So inverting comparator means if the input is high, that is V1 high means output will be 0. If V1 low means output will be 1. That is reverse operation. Non-inverting means as well as same as concept. That is, V1 greater than means output 1. V1 less than means output will be 0. Okay, let's see the diagram. So that is non-inverting input, inverting input, V plus and V minus. So in this circuit, the value up to 0 to V reference, the value will be 0. So after V reference, okay, so value will be 1. So after this value, so value will be 0. So it will be like this. Okay, same concept will be defined in the output. That means we are going to take the signal, any one of the signal, and we are going to set the reference. Okay, so like that we can define the different output signals. So a comparator maximum used in the Windows models. Okay, window comparator. So window comparator means it is compare 3 levels. Okay, here we are in the previous model we are comparing the only 2 signals, but in the comparator model we are going to take the 2 reference voltages. That is a low threshold voltage, high threshold voltage. The difference between these two will be get the output. So this is the circuit for non-inverting comparator. So generally it is connect the protection diodes. So because it is an open loop model, so the power supply will affect the input. So we are using the diodes, protection diodes. So if you are giving input to that is a V in value given to the positive terminal, that is non-inverting terminal, means it is a non-inverting comparator. Okay, so that means 0 to V reference 0, V reference to up to this value it will be 1. So remaining value will be 0. Like that it will be defined. Okay. So in the inverting comparator circuit, so the value inverting comparator circuit, that we are giving input V input to the inverting terminal. We are giving reference voltage to the positive terminal. Okay. So this is the circuit, that is inverting model. That means 0 to V reference means here V value will be 1. So for this value will be 0. That is the reverse operation of the non-inverting comparator. So these are the characteristics to define